Good morning, 7th graders. Hope this finds you doing very well this morning. We are on page 27. Yesterday we talked about how probabilities always got to be between 0 and 1. Okay, it's 0% of the time going to happen, 100% of the time going to happen, or somewhere in between. So sometimes we're going to have decimals instead of fractions, and we're going to have to figure out which one is more likely. So it does want us to label these on a number line. All right, so I'm going to put half, which would be 0.5 in the middle. I'm going to put 0.75, which would be halfway between 0.5 and 1, and 0.25 here. And hopefully that's enough information for me to just plot these points. The first one, A, would be 0.5. B, 0.75. 0.33, that's 33% of the time, so a little closer to 0.25 than 0.5. D, 0.67, so again a little closer to D or B than A, and 0.25. All right, number 2, choose one of the numbers in previous question, describe a game. So half, you could have done flipping a coin, getting a heads. This would be a third. Let's do that one since it's a little different. Okay, describe a game. Spinning this, we'll say they're equally spaced, even if my spinner doesn't look like that. And so the probability of spinning that and getting an A would be 1/3, which is 30.3 repeating percent. Okay. I'm guessing that's what they meant there. All right. And again, the easiest one would have been half. Flipping a coin, getting a heads. Next page. Maya's playing a game which she only wins if she rolls a 1 or a 2. Okay. So winning a 1 out of 2, and again you can do the interactive one and do this yourself. List all the outcomes in the sample space for rolling a number cube. Remember, sample space means I have to list them all. Okay, I have to list them all. 1, 2, 3, 4, 5, 6. What is the probability that she will win the game? Okay, well, she's going to win with a 1 or 2, so 2 out of 6, or 1/3 of the time. Want it as a decimal, you could do 0.3 repeating. 3, if Maya is given the option to flip a coin and win, is that a better option for her? Okay, so flipping a coin and getting a heads would be 1/2. Is it a better option for her to flip the coin or to roll the dice? Okay, hopefully you can see that 0.5 would be bigger than 0.3 repeating, so definitely flipping a coin would be better. Number 4, with your group, follow these instructions. Okay, so we're just going to do this together. 10 rolls. I'm going to do the outcomes. Then we're going to keep track of the wins, and then we're going to keep track of a fraction and then plot them. Okay, remember, in theory, we'd get about 0.3, so our graph would level off at 0.3. The more tests we do, the more accurate, the more closely we should get to 0.3. So let's check. This is experimental probability because we're doing an experiment. So I'm going to roll it 10 times. 5, 2, 4, 4, 6, 1, 5, 1, 3, 2. All right. Total number of wins. 0 wins, 1 win. Still have 1 win. I still have 1 win. I still have 1 win. 1 again. No win. 1 again. No win. So I won a total of 4 times. Okay, fraction that are wins. So it's 0 out of 1. I've won 1 out of 2. I won 1 out of 3. I lost, so I won 1 out of 4. I lost again, so I'm 1 out of 5. Then I won, and I'm at 2 out of 6. I lost, so I'm at 2 out of 7. I won, so I'm at 3 out of 8. I lost, so I'm at 3 out of 9, and I won. I'm at 4 out of 10, so probably a little better than we would expect. And I'm also going to divide them out because I see that this is in decimals. So this would be 0 divided by 1, 1 divided by 2, 1 divided by 3, 1 divided by 4, 1 divided by 5, 2 over 6, which is 1 divided by 3, 2 out of 7, I don't know that one. 2 divided by 7, 0.29. 3 to ace, I believe that's 375. 1 out of 3 again, I reduced it. And 4 out of 10, which is 2/5, 0.4. All right, so I'm at 0. Went up to 0.5, 0.3 repeating, 0.25, 0.2, 0.3 repeating, 0.29. Oh, 0.3 repeating would be higher than that. Because 0.29 would be here. 0.375. Oh, I'm off one. Which one did I miss? I missed 0.25. 0.5, 0.3 repeating. Which one did I miss? Oh, I started at 0. That's the problem. First roll, that one is 0. Sorry about that. Roll 2, roll 3, roll 4, roll 5, roll 6, roll 7, roll 8, roll 9, and roll 10. Okay, so again, the more rolls we do, the more accurate our experiment should be, and we're expecting this thing, notice how it's starting to level off, should be really close to 0.3 repeating. Okay, that's our goal. That should be our theoretical. Our experiment should be more than that. Now, it could have happened that I had all 10 of these 1 and 2, and I would have been way up here the whole time. Or I could have gotten 0 of them and I've been down here. But it should level off the more experiment we do, the more trials we do. Okay, what appears to be happening to the points of the graph? Well, it looks like they're kind of going up and down, leveling off close to our number. So we'll put a little note there that they are starting to level off. After 10 rolls, what fraction were a win? That was 4 out of 10, or 2/5, which was 0.4. It does say fraction. How close is that to the probability that we'll win? Well, how close is 0.4 to 0.3 repeating? I would say it's very close. Then we're going to do it 10 more times. Okay, I'm just going to make a note that I had 4 out of 10 on the other side. 10 more times. 2, 3, 4, 1, 1, 2. It's a lot of wins. 3, 4, 4, 4. Okay, so there's an example of probability. Okay, I didn't get any 5s or 6s, and I got 1, 2, 3, 4 4s out of 10. 40% of the time I got a 4. All right, so total wins. I had 4 from the previous, so this is a win, so that's 5. Still have 5. Still have 5, 6, 7, 8 wins. Not a winner. Not a winner. Not a winner. Not a winner. Okay, so fraction, this is out of 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 total rolls. And I have 5 winners. And then I have 6 winners. And then I have 7 winners. And I end with 8 winners. All right. So again, to help me plot those, I'm going to divide them out. 5 divided by 11, 0.45. 5 divided by 12, 0.42. 5 divided by 13, 0.38. 6 out of 14 should reduce that, 0.43. 7 divided by 15, 0.47. 8 divided by 16, 8 divided by 17, 8 divided by 18, again reduce that, 8 divided by 19, and 8 divided by 20. Okay, after 20 rolls, what fraction was a win? 8 out of 20, which would reduce to 2/5. How close is it? Well, it's very close again because it was the exact same after 20 as it was after 10. So I'm going to put very. I'm just going to plot those guys with the other ones so you can see how close they are. So let's see, 11, 0.45, and 0.42. 0.38 and 0.43. 0.47 and 0.45. 0.47 and 0.44. 0.42 and 0.4. So again, hopefully you can see that, you know, it's starting to kind of level off again. Again, our goal is to get to about right here. That's what should happen in theory. Every experiment's going to be different. You could roll it again and have something completely different, and that's just an example. But we would expect if we did 100 trials, it would be close to that. Final question on page 32. Do you think it's surprising or not? So, surprised or not? You flip a coin and it lands heads up. Is that surprising? Not really. Okay, it's certainly possible. Flip a coin twice, it lands heads both times. Okay, a little more surprising that you get heads twice, but not really. I mean, it's certainly possible. How about if you flip a coin 100 times and you get 100 heads? Okay, that would definitely be surprising. Okay, to get 100 heads flipping coins in a row, that's craziness. Number 2, if you flip the coin 100 times, how many times would you expect to get heads? Okay, well, heads is half of a coin, so I should get it half of a time. Again, in theory, how many times would I expect? I would expect I would get it 50 times. C, if you flip a coin 100 times, what are some other results that would not be surprising? Well, I would expect it to be around 50, but I know it's not going to be exactly, so anywhere between 40 and 60 times I would probably get a heads. I would probably say that's reasonable. And number 4, you flip a coin 3 times and it comes up heads once. It says the cumulative fraction of heads is currently 1/3. If you flip the coin one more time, will it land heads up to make it 2 out of 4? Okay, so it says you flip a coin 3 times, you get 1 heads. So let's say we got heads, tails, tails. Okay, so I got heads 1 out of 3 times. Okay, would we expect if we flip it again, because we know it should happen 1 out of 2 chances, if we flip it a 4th time, are we guaranteed to get a heads? Okay, because we should get a fraction of 1/2 or 2 out of 4. Okay, there's no guarantee. It is by chance. So we have a 50% chance of getting heads, yes, but we also have a 50% chance of getting tails. Okay, so would we expect it to land heads up? I would say not necessarily. Okay, not necessarily, because it's got just as good a chance of being a tails. All right, so that is it for today, guys. Your homework is on page 34 through 35, those 5 problems, all right? Hopefully you continue to stay safe and healthy, and we'll talk to you soon.